All right, here is the test review for right triangles and trigonometry. So let's get started with this vocabulary. All right, I'm going to start with the definitions. So the longest side of a right triangle is called the hypotenuse, so that would be A. The two shorter sides of a right triangle are called the legs, so that would be B. The angle formed when looking up at an object is the angle of elevation, so that would be C for number 2. The sum of the squares of two legs of a right triangle equals the square of the hypotenuse, or A squared plus B squared equals C squared. That is the Pythagorean theorem. Right triangles with a specific angle measurement or side ratios that make them easier to calculate, i.e. 30, 60, 90 triangles and 45, 45, 90 triangles. Those are special right triangles. The number multiplied by itself to equal another number, that would be a square root. The angle formed when looking down at an object is the angle of depression. And three integers for which A squared plus B squared equals C squared is Pythagorean, those are Pythagorean triples. And then the ratios of the sides of the triangle, sine, cosine, or tangent, those are trig ratios. And then a right angle with two congruent legs, a right triangle, with two congruent legs is an isosceles right triangle. All right, so for numbers 11 and 12, we're going to solve for x, and we're going to write the answer in simplest radical form and in decimal form to the hundredths place. So this is a Pythagorean theorem problem, and I can tell because I know two sides and I'm looking for the third side. So that's going to be the hypotenuse is there, and then this could be A, this could be B. So that'll be A squared plus B squared equals C squared. So we're just going to plug in what we know. So A is 12, B is 8, and C is unknown. So I'll just put the X there. And now we're going to solve for X. So what you can do is, scoot this over, because we're going to need more space. All right, so 12 squared is 144, 8 squared is 64, and then the X squared stays the same. Now we're going to add 144 and 64, and that should give us 208. And then last step we need to do is take the square root. All right, so to do that, what we can do is just take the square root on your calculator to get the decimal form, and then we could also find the, the prime factors of 208 by doing menu 2, 3 on your calculator, or you can just build a factor tree and break it down. All right, so that'll be 2 times 2 times 2 times 2 times 13. And now we're going to take out the doubles. So we have a double 2. We have a double 2 again. So that's, we take out a single for every double under the radical. And then we have the 13 that stays underneath. And so just to clean this up a bit, that would be 4 square root of 13 in simplest radical form. Oops, sorry, y'all. In simplest radical form, or we could put it in decimal form. 13 as 14.42, rounded to the hundredths place. All right, go ahead and try number 12. Number 13. Jackie is standing 83 meters from the base of the Empire State Building. So I'm gonna draw that picture. Pretend that was a terrible, okay, wait, hold on, we got this. Yeah, there we go, yeah, Empire State Building, boom. All right. The building, I'm sorry, she's standing 83 meters away. So, hey, I'm Jackie. Okay, which equation would help you find the angle of elevation? All right. So, and the building is 380 meters high. All right, so we're not taking her height into account because they didn't give us her height. So we're not even going to take that into account here. So theta is going to start from her feet. The angle of elevation will start from her feet. Okay, and I'm going to move this. I don't know if that'll be helpful or not, but I'll put it right there so we can focus on the right triangle that we created here. All right, so we need an equation. So let's go ahead and label these sides. This would be theta, of course, and then the 83 is the adjacent side, and the 380 is the opposite side because it's across from theta. This is the hypotenuse, but it's blank, so I'm not even going to worry about that. So we have adjacent and hypotenuse. If we use SOHCAHTOA, we can figure out which ratio would work best for this problem. And again, we have opposite and adjacent, so that would be tangent. So the T in TOA stands for tangent theta, the O stands for opposite, and the A stands for adjacent, which are the two sides that we had in the problem. And so when we plug in, we are going to have tangent. We don't know what theta is, so you can put an X or you can keep it as theta. Since we don't know, it doesn't really matter. And then for opposite, that would be 380. And then adjacent was 83, and we can stop there. It's just asking us for an equation. We could also use the inverse, so tangent inverse, and then we'd put the 380 over 83, and that would equal x, so we could also do it that way. All right, go ahead and try number 14. Number 15, which sets of numbers are Pythagorean triples? So let's take a look. So we're just gonna use the Pythagorean theorem to verify if these three numbers are gonna make it true, sorry. All right, so 9 squared is 81, 40 squared is 1600, 41 squared is 1681, and these are equal because if you add these two over here, it'll give you 1681. So yeah, we're good to go. This would work. Same number, but next set of numbers. We got 9 squared, 12 squared, and then 15 squared. I don't know if they're equal yet. So we got 81 for 9 squared, 144 for 12 squared, and then 225 for 15 squared. Now when we add the 81 and the 144, that's going to give us 225, which is equal to 225. So this one's good as well. All right, let's try the last one. 4 squared plus 5 squared. Let's compare it to 7 squared. So that'll be 16 for the 4 squared, 25 for the 5 squared, 49 for the 7 squared. If we add 16 and 25, that'll give us 41, which is not equal to 49. So nope, not that one. Go ahead and try number 16. All right, number 17. What is the measure of angle A to the nearest degree? So angle A is theta because that's what it's asking us for. 61 is across from the 90-degree angle, so that's the hypotenuse, and then 11 is next to theta, so that's the adjacent side. The opposite side is blank, so we will ignore it. If we use SOHCAHTOA, I forgot the H, which one has hypotenuse and adjacent? That would be ka, if you will, or cosine. The C stands for cosine theta, the A stands for adjacent, and the H stands for hypotenuse. So we're going to solve this equation. Let's go ahead and fill in what we know. We know that cosine is unknown, so I'm going to put an X right there. Move this down a little bit. Oops. And then adjacent is 11, hypotenuse is 61. Now, since X is not in the fraction, multiplying by the denominator will not be helpful. So what we're going to do instead is use the inverse. So cosine inverse over 61 of 11 over 61 equals X. So when the angle is missing, use the inverse. You're going to type that into your calculator. And pretty much exactly how it looks. Just don't put the equal sign, don't put the X. All right, so that'll give us 47 degrees because we're rounding to the nearest degree. Go ahead and try number 18. And now we're looking at number 19. One end of a 12-foot ladder is 5 feet from the base of a wall. So let's draw that. We got this ladder. Goodness. And it says that it's a 12-foot ladder? Yes. And it's 5 feet from the base. And we're trying to figure out how high on the wall, so we want the height. And we want to round to the nearest tenth. Okay, so we have this nice right triangle over here. And we know 2 sides of the triangle. We're just looking for the third side. So that means we can use Pythagorean theorem. So let's label it for Pythagorean theorem. All right, a squared plus b squared equals c squared. And let's plug in what we know. A, we put an x there. We don't know what a is. 5, we can put 5 squared. And then for c is 12, so that's 12 squared. The x squared stays the same. 5 squared is 25. 12 squared is 144. Since x is on the same side as the 25, we're going to have to subtract 25 to get the x by itself. All right, 144 minus 25 is 119. And we're going to round to the nearest tenth when we take our square root per the instructions. And so that gets us 10.9. Go ahead and try number 20. All right, number 21. A rescue helicopter pilot spots a stranded fishing boat. The angle of depression is 35 degrees. All right, so angle of depression, excuse me, I already know it's going to look like this. That's what the triangle looks like. And then there's like a helicopter over here. That's a beautiful helicopter. Yep, okay, well, struggles. And then it says that the angle of depression, which is here, is 35 degrees. And the altitude is just another word for height, is 1,800. And we're trying to find the distance between the helicopter and the stranded boat. This is the boat down here. Help, I'm stranded. Okay, I'm gonna change colors real quick. And now we're gonna label our triangle. This is obviously the right angle. So if this is theta, that means the side across from theta would be the opposite. So the 1,800 is the opposite. And of course, x is across from the 90s, so that makes x the hypotenuse. The adjacent side is blank, so we're just gonna leave it alone. And now let's get into figuring out which ratio to use. So, ka, toa. And real quickly, I know that I have to use so, ka, toa, or sine, cosine, or tangent because it gives me an angle and it gives me one side only. If it gave me 2 sides and I had to find a third side, that would be Pythagorean theorem, but that is not the case here. So we're gonna have to use trig ratios. With that in mind, we got hypotenuse and opposite. The only one that has opposite of hypotenuse is sine. So that's going to be sine theta equals opposite over hypotenuse. Sine, and then theta is 35 per the picture. Opposite is 1,800, and then x is the hypotenuse. And honestly, we can stop there because it just says to write an equation. So this equation could work. We could also get the equation to isolate the x. So that would be, if we multiply both sides by x times sine 35 equals 1,800. And then we would divide both sides by sine 35. Remember, they have to stay together. So another form of this equation could be x equals 1,800 over sine 35. So that's another way you could write the equation. But, you know, yeah, just giving you different ways you could write it. But this way is the simplest way, I suppose. Go ahead and try number 22. All right, number 23, what's the value of x in this triangle? So right off the bat, there's a lot going on, and yet not enough, right? So I see that these markings are there, which means this is also an x, which means, technically we could use Pythagorean theorem to figure this out because these sides are equal. I'm not going to do that, but you could do that. Mathematically, it would work. However, if these two sides are equal, that makes this an isosceles right triangle, aka a 45, 45, 90 triangle. So now we can use the 45, 45, 90 rules. You could also use SOHCAHTOA because you know the angle is 45, you know the hypotenuse is 2, and x would be the adjacent, or x would be the opposite, depending on which one you wanted to use. So we have choices, is all I'm trying to say. But I will use the 45, 45, 90 rules, which states that the hypotenuse divided by the square root of 2 will equal the leg. So 16 square root of 2 is the hypotenuse. If I divide that by the square root of 2, that's just going to cancel out, and that'll leave us with 16. So x is 16. Go ahead and try number 24. 25. We're just writing the ratios based on the picture. So we're using b as our theta because it says b for all three of these. So let's label our triangle accordingly. This would be our opposite, this would be our hypotenuse, and this would be our adjacent. All right, we know that sine is opposite hypotenuse, so that would be 9 over 15. And if we simplify that, that would be 3 over 5. Cosine of b, would be adjacent over hypotenuse. So that would be 12 over 15. And let me move this out the way. So that would simplify to 4 over 5. And then we've got tangent, which is opposite adjacent. So that would be 9 over, sorry, that 9 looks janky. That didn't help. All right, over 12, and that's going to simplify to 3 over 4. All righty, go ahead and try number 26. 27. Given the triangle below, calculate the length of the side labeled with x. So we can use SOHCAHTOA. We can. I'm not, but you could. I'm going to use 30, 60, 90 rules because they're easier. They're simpler, let me say that. So this would be our hypotenuse. Not that we really need it, so I could have just left that alone. This would be the short leg. This would be the long leg. And so the rule states that short, the 30, 60, 90 rule is that short times square root of 3 equals long leg. So that'll be 5 times the square root of 3 equals x. So 5 square root of 3, if you want to clean it up a little bit, you don't have to, equals x. All right, go ahead and try number 28. All right, 29. Given the right triangle below, determine the length of the side labeled with x. All right, so this is not a special right triangle. It's not 45, 45, 90. It's not 30, 60, 90. So we're going to have to use trig. So, SOHCAHTOA. So let's label. This is theta. This is the hypotenuse. And this is the adjacent side. Which one of these uses hypotenuse and adjacent? That would be cosine. C of ca stands for cosine theta. The A stands for adjacent. And the H is hypotenuse. So now we are going to plug in what we know. So we know that theta is 42 degrees. We know that adjacent is x and hypotenuse is 12. Now we have to solve for x. X is in the fraction. So we're going to have to multiply by the denominator on both sides to get x by itself. In your calculator, you're going to type this. Oops, you're going to type this. And don't forget, your calculator needs to be in degree mode. So once we type that in, let's see, 12 cosine 42, and I'm in degree mode, 8.9. We're rounding to the nearest tenth. Well, shucks, let's try that again. Okay, and number 30, oh, go ahead and try number 30.